Okay, so today's lesson is actually an important lesson. It's something that obviously you have to be able to do for this course, but also for grade 12. So our goal today is from the ratio, I can determine all the angles, plural, that exist. Okay, so remember when we did that major lesson that took so long and it dealt with the unit circle, and we discovered that sine, for instance, had if I had its ratio, it could be in, and it was positive, it could be in the first quadrant or in the second. Well, those things are going to be true for other things as well, and you discovered that when you actually worked on the package. Okay, so when given the ratio of a trigonometric equation in almost all cases, there are two angles that would give you the same ratio. Okay, and this occurs because point P is defined as a coordinate, and the coordinate is cos theta sine theta. And in the Cartesian plane, we know x is positive in two quadrants, and y is positive in two quadrants, just like it's negative in two quadrants as well. Okay, and also it's important for us to remember that tan, it consists of sine theta divided by cos theta, so that quotient identity. Okay, so that's important because this positive and negative is going to affect the ratios for tan theta as well. So positive and negative trig values. Okay, so what I have done here, and this is kind of just a review of what you did when you did some discovering with the ratios with the unit circle, is I have an angle in all three quadrants. Sorry, all four quadrants. There's four of them, believe me. That's why it's called quad. So if I take my calculator and actually calculate these, there's no issue, right? Because it's when I go from the ratio to the angle that could be an issue. So I'm going to bring this up and I'm just going to very quickly type these in so that we can see what we have. And I'm not as concerned about the number, the ratio itself. I'm concerned about its sign, whether it's positive or negative. Okay, so you can see that we have all of these are positive. So actually, if I take and positive, positive, positive. And actually, this was 0.9 something or another. So let's actually put that down. And the other one was 0.4. So I'm just going to take the first decimal place. And this one was 2 decimal something or other. 2 decimal 1. Okay, no problem with that. Okay, now if I take quadrant 2, and this time I'm going to do the same kind of thing. That's positive. Oh, it's positive 0.9. Oh, that's interesting. You're saying, yeah, sure. You probably know what it means, Mrs. Broadhagen. Yes, I do. And then tan of 115. Oh, okay. So I have a positive for the sine, a negative for the cos, and a negative for the tan. So positive 0.9, negative 0.4, and a negative 2.1. Okay, just to check again. Yes, that's what we have. Okay, let's go into quadrant 3. You maybe are guessing what all of these will be. 245, 245. Okay, so this time we have sine and cos are negative, and tan is the positive one. Notice those same decimal numbers again. So we have negative 0.9, negative 0.4, and positive 2.1. All right, so let's go to the next one. All right, so we'll clear it. So sine of 295, cos 295, and tan, I think it's going to be negative 295. And it is. Okay, so we have negative, we have positive, and we have negative again. Now, hopefully you discovered what was going on here. Remember that we know that we have cos theta, sine theta. This is the coordinate system, and so this is our x, and this is y. So if I think of first quadrant, both x and y are positive in that quadrant, okay? And that is why these are positive. When I get into the second quadrant, and we saw this before, sine is positive because sine is y. Okay, so if I just bring that up again, so we have positive, positive for our coordinates. This is negative, positive, and this one is, and I'll do this down below in a second, and this is negative, negative, and we have positive, negative. And it follows that for the sine and cos. Okay, and because tan is made up of sine divided by cos, wherever sine and cos are both negative, tan is positive. So in this location, you notice both the sine and cos are negative, which means you have a negative number divided by a negative number because of this. So you end up with a positive number. So this is where it comes from. Okay, it has to do with this. Now this is important for us because that tells us in which quadrant an angle could be in. So because I said there are two values, two angles that have the same trig value, it is. If I look at this trig value 0, positive 0.9, it happens here. It also happens here. So it happens at 65 degrees and it happens at 115 degrees. Okay? The same is true when it's negative 0.9. There are two locations where that can happen. And it will do this for every single one. There's two places where we have a positive decimal 4. Okay? For cos, it's in the first and fourth quadrant. Okay? And there are two places where tan is positive 2.1. It's in the first and third quadrants. Okay, and obviously then the other ones, they're negative. So that's important for us, and we need to know that. We need to be able to use that. We need to be able to use that information. So what someone has come up with is what they call the CAST rule. And the CAST rule has been around for a long, long time. Some textbooks um, didn't put it anymore in them, but your textbook does talk about it as well. So what it means, and it's important for you to know this, is that we call it CAST because it's just a way to remember where everything is positive and negative. And so I'm just going to lock this in place. Okay, so CAST, notice it starts in the fourth quadrant and it goes C-A-S-T. It's just a way to remember. So cos is the only ratio that's positive in the fourth quadrant. All of them are positive in the first. Only sine is positive in the second. And only tan is positive in the third. Okay, so that's important. So that's what we need to use is the CAST rule. So what I'm going to do now is I'm going to go on to the next page and we're going to actually go from a ratio to its angles. And we need to use this piece of information as well as our calculator to calculate these. Okay, so it says for us, find the values of theta if we have thetas between 0 and 360. So as soon as they say this, we know that we could have acute angles and obtuse angles. The first thing that I always do is and I have a whole bunch of them that I'm going to just make bigger when I work on the next question. Or maybe I won't use that one. I'll just use this one and clone it so that I have it. So the first thing I do is I look to see. Okay, and I'm just going to put it here and we'll put our work underneath here. So there's a lot of thinking involved here, not a lot of writing down. So that can be an issue with us sometimes. The first thing Is the ratio positive or negative? It is positive. Where is cos positive? It is positive here and it's positive here. So that means that in those two locations is where my terminal arm is going to be located. Okay, so I'm just going to draw it so you can visualize it. So we know we have one terminal arm that is located here. Okay, and you've seen me draw a right angle triangle before. And there's another one that's located here. Okay, because they have the same x value. So they have the same x value here and here. That's why they both have the same ratio. All right, so my first angle, then I'm going to get from my calculator and I'm going to type it in and it's going to tell me what it is. Okay, so up comes the calculator. We're going to clear it. Turn it on first, clear it, and we're going to take the cos inverse of decimal 1269, and it tells me it's approximately 82.7 degrees. So that's something that I can write down. So we would write down then the cos inverse of 0.1269 equals, what did I say, 82? I forgot already. 82.7. Obviously, that's the one that's located in the first quadrant. So my first theta is equal to 82.7. My second theta, the way we get our second theta is these triangles over here are identical. They're identical except they are flipped. So they're just flipped around. So going back to this, it's just flipped down. So this triangle is actually a mirror image of this one. So we know that this one equals 82.7 because we found it in the first quadrant. So in order to get that, we would go around because we want positive because they want a positive theta. The question, if you notice, is between 0 and 360. Okay, so we're going to go 360, take away the 92 or the 82.7. Okay, so second one is going to be 360, take away 82.7. And when we do that, we would bring up our calculator, we do it in our head, and I'm not thinking, so we're going to use the calculator. And when we do that, we end up with 277.3. Okay, so those are the two angles that give us the positive ratio for cos of 0.1269. Okay, so not a whole lot of work here showing, but we have to do an awful lot of thinking in order to get our angles. So it's almost at 14 minutes, so I'm going to pause, actually stop, and create a new video, and we'll do these next two. Okay, so actually practicing with this works very, very well.